Hopefully this video will finish up section 2.7. The first thing we're going to do in our first problem, 4 times parentheses 3x minus 1 is greater than 3 times parentheses 2 minus 5x. The first thing I'm going to do is distribute my 4 through and distribute my 3 through. So I get 12x minus 4 is greater than 6 minus 15x. I always want you to get your x's to the left. That's going to make interval notation much easier. So even though the 15 is a bigger number, I'm going to move the 15 over because that's going to put it on the left side, and that's where I need it to go. 12x plus 15x is 27x minus 4, and that's greater than 6. Working on the x side first, I'm going to move the 4. So 27x is greater than 10. Remember, you're still working on the x side, so I'm going to move the 27, and I get that x is greater than 10/27ths. Writing this answer in interval notation, I would start with 10/27ths and move to the right, which would be to infinity. Infinity always uses parentheses. The problem here is greater than. Since it's strictly greater than without the equal bar, that means you're going to use parentheses. So my final answer is 10/27ths to infinity, all in parentheses. My next problem is x divided by 4 minus 3 is greater than or equal to 1. I'm going to start by turning all of these whole numbers into fractions. I'll place the 3 over 1. I'll place the 1 over 1. To get rid of these fractions, I'm going to take my denominator, which is 4, and multiply all the tops through by 4. In my first fraction, a 4 in the top and a 4 in the bottom cancel and leave me with an x. In my second fraction, I have 4 times 3, which is 12. That's greater than or equal to. In my last fraction, I have 4 times 1, which is 4. Now I no longer have fractions, which is great. To get the x by itself, at this point, I'm going to add 12 to both sides. And x is greater than or equal to 16. So writing that in interval notation, it would be 16 and to the right, which would be 16 to infinity. Infinity always takes parentheses. The 16 here had the bar under the inequality, which means the 16 is going to take a bracket. So my answer is 16 to infinity, 16 having the bracket. Remember I said to get x on the left. That's going to be a major concept when we look at this last group. So since I just mentioned getting x on the left, let's work the second problem. 4x minus 7 is greater than 9x minus 2. I want the x on the left. Even though 9's a bigger number, even though we're accustomed to move the smaller number, move the 9. So I'm going to subtract 9 from both sides, and I get negative 5x minus 7 is greater than negative 2. I'm going to move the 7 over, so I'm going to add 7 to both sides. Negative 5x is greater than 5. To solve now, to get the x by itself, I'm going to divide both sides by negative 5. But when you divide by a negative, you have to flip your sign. So x is less than negative 1. In interval notation, I see it's pointing towards the left, which means that we're going to start at negative infinity, which is on the left, and go to negative 1, and negative 1 uses parentheses. We're finally to our last problem of section 2.7. Our last problem says negative x is less than negative 5. Remember, that's understood to be a negative 1x. So to solve this problem out, I'm going to divide both sides by negative 1. But when I divide by a negative 1, I have to flip my sign. So x is greater than 5. Two negatives would make a positive 5 there. Writing this in interval notation, I would start at 5 and go to the right, which would be infinity. 5 is going to take parentheses since it's strictly less than.